All right, guys, we're going to continue looking at the remainder theorem. We're going to use the remainder theorem to see, is the binomial a factor of the polynomial? So just a little refresher, the remainder theorem, if a polynomial p of x is divided by the binomial x minus a, and a is just some number, the remainder obtained is p of a. Okay, so what does this mean? This means if we have a binomial, okay, down through here we have binomials, and we have the opposite of a. So we're going to do the opposite of this in order to plug it in to find p of a, which is the remainder. All right, so for number 1, we'll call the first one number 1. So p of, since that's negative 1, x minus 1, negative's part of the problem, so it's going to be the opposite, which is just p of 1. The next one's going to be p of 3. The next one's going to be p of negative 3, because negative 3 becomes plus 3. And then p of 4. And the last one is p of negative 4. All right, so we're going to use the remainder theorem to see if each of these is a binomial of the polynomial above. Okay, so that we're given this polynomial x cubed plus 4x squared minus 9x minus 36. All right, so using the remainder theorem, we're just going to plug in a for x. Okay, remember that this is p of x, or p of a in this case, but a is just the number, but it's always your value of x. And so we're going to do 1 cubed plus 4 times 1 squared minus 9 times 1 minus 36. And then the next one, we're going to do 3 cubed and you can see I'm just using the same polynomial up here, and I'm replacing it with what a is in this case. This one's negative, so I need to put it in parentheses. And you do the same thing down here and down here. I'm going to let you guys figure that out with writing that out for each one of these. I want you to take a moment and pause the computer for a second and figure out, just take these and plug them into your calculator and see what you get for p of 1. Do the same thing for p of 3 and each of these. Okay, so just write the remainder out here to the side, and then we'll talk about what that means. All right, guys, hopefully you've taken time to go through and get each of these, and you can see that if you substituted 1 in for this polynomial, you should have got negative 40. That means the remainder of this polynomial is negative 40. So what does that mean in terms of whether it's a factor or not? All right, if the remainder is 0, that means the binomial is a factor and will factor out evenly. If the remainder is anything else, positive or negative, it means the binomial is not a factor. So for p of 1 equals negative 40, this one is not a factor. All right, we substituted 3 in. When we simplified that, we get 0. If you get a remainder of 0, then this binomial is a factor. The next one we plugged in, we got 0, so yes, that is a factor. The next one we got 56, positive or negative. It's not a factor unless it's 0. And the last one we got 0, so that one is a factor as well. All right, so let's look and see. We had 3 of these, the second, third, and last one. Okay. All right, guys, you can see now I've added the factor theorem here. So if we have used the remainder theorem and we've decided is the binomial a factor or not, we did that by substituting in and seeing if the remainder is 0. So the factor theorem states if you have f of a and it is 0, that means that x minus a must be a factor of the polynomial. So if this is a factor of the polynomial, that means we should be able to factor it completely. So let's see what that looks like. We're not going to check number 1 because it's not a factor. We've already said that's no. That means we did not get a remainder of 0. For the next one, we did get a remainder of 0, so let's see what that looks like. So if I take negative 3, I'm going to use positive 3, so I can do synthetic division. And I'm going to bring down my coefficients, 1, 4, negative 9, and negative 36. So we're going to bring down the 1. We're just doing synthetic division. 3 times 1, 4 plus 3 is 7. 3 times 7 is 21. Negative 9 plus 21 is 12. And 3 times 12 is 36. All right, so this tells us that we factored x minus 3 out of x cubed plus 4x squared minus 9x minus 36. So when we do that, x divided out of x squared means we start with 1 less. So 1x squared plus 7x plus 12, and the remainder is 0. So if this is a factor, that means I'm going to be able to factor this even further. So if you remember back when we were doing factoring, you can rewrite this as 2 binomials. So you're going to have x times x is x squared. Well, it multiplies to give me 12 and adds to give me 7. 3 and 4. Now, this is 2 of our binomials. But you know if you multiply x times x, you're getting x squared. So our third one is the one that we checked over here. So this is the one that we started with. That's where we got the 3 to do synthetic division. So that is also one of your factors. So you're going to bring that over here and say x minus 3. Okay, so now if you multiply all 3 of these binomials together, you are going to get the polynomial that you started with. So let's check that. All right, guys, I erased and just wrote the factors there so that we can see I have room to work this out. So we're trying to see if the 3 factors, when we factored out, we did division by taking x minus 3 and dividing it into this polynomial using synthetic division, and then we completely factored to get these other 2 factors. So we have 1 factor here, we have the other 2, and we're going to multiply this back to show that it is the same as the original polynomial. So x times x is x squared. X times 3 is 3x. Minus 3x cancel. Negative 3 times 3 is negative 9. Bring down the third binomial. And now we're going to have x squared times x is x cubed. X squared times 4 is 4x squared. Negative 9 times x. And negative 9 times positive 4. So you can see that this was 1 factor. We found the other 2 factors by using division. And then we multiply. Multiplication is the opposite of division. We multiplied those 3 factors together back to get the original polynomial. So this only works if the remainder is 0. So if you see a question where it says, is the binomial a factor of the polynomial, you can use the remainder theorem to see if you get a remainder of 0. If you get a remainder of 0, then yes, the binomial is a factor of the polynomial.